Hello, everyone. As Hugo said, it's the usual agenda for this STC 13, like the previous ones. So this day, first day, is dedicated to roadmap. So the idea is to do some roundtable and some discussions around what has been done around so far in the last 6 months and what we plan to do in the next 6 months. And at the end of the day, we want to build a roadmap and to put it online for everyone to know what we plan to do for the next 6 months around SOFA. Days 2 and 3, as usual, will be dedicated to technical discussions and coding sprint. So maybe you can go next. So yeah, I just said that.
Yeah, it's going to be for today. It's going to be we're going to start with really a few news about SOFA in general, what's happening and what's new, and then that's what I mentioned earlier. Really, the roundtable where anyone can take time for first just saying like what for remote people or for the recording as well, who you are, like engineer, PhD, postdoc, and so on, what you're working on, and what you did work on in the last 6 months on so far, and what you're going to do in the next 6 months.
There is a possibility if you want to show some slides or some video or some anything if you want, but you are not. It's not a presentation.
And yeah, if you want to display anything, you can join the stream. There is the link.
If you go on the link on the bottom left, STC 13, you will have everything from this page. The agenda, the notes, the link to join the conference, everything.
And once we've made the roundtable, then there will be the summary of the previous roadmap tasks, and we're going to discuss that. So there were the contributions on, as we said, 6 different topics. I can take
the topics were topologies, coupling SOFA and Phoenix, SOFA NG for next gen, matrix assembly, AI, couple SOFA and machine learning, and lastly, simulation on beams with the Cosserat plugin and beam adapter.
So those 6 topics will be discussed, and then that will be for the afternoon. It's going to be more defining what's going to happen in the next 6 months based actually on what we're going to discuss this morning. What's going to be the things you're going to work on? Is that something which is like 100% sure or not? If it's sure, then we could directly add it on the roadmap. If you are looking for people assisting you in the tasks that you would like to start, that's also something that is possible today. And the idea is to give visibility for your work and also to give it more clarity and easiness to read what's going to happen in the next 6 months for the community. And for each of those like possible future roadmap topics, the idea is always to list a few tasks, like a few points, because if we don't like make this small effort, the idea is that topics are rising and we don't really know what is supposed to be achieved or not and so on. And finally, actually, when we do things like that, at least from experience, the things are, I mean, the work is actually not really progressing.
We will repeat it all the day now. But what we want is not to build a roadmap on wishes, but on what we will actually do.
Because since we're like between PhDs, engineers, and interns, that's what sometimes happens with researchers. I can talk. I mean, I can say that while Christian is not there yet, but he's. Some of the researchers sometimes are like wishing a lot of things to happen in SOFA. That's wishes, but when you don't have actually people to do that, we could actually keep the same wishes for years if there is no one to work.
And actually, we don't care if there is one point only on the roadmap. We just want to be sure that it's something that will be achieved or at least evolved in the next 6 months.
All right, and the end of the day, objective is to get these topics and some few sub points for some tasks for each of those topics. And then, as Guillaume said, days 2 and 3, you can already check out the STC 13/Spring for seeing the various topics that were during those last weeks and months noticed as issues or problems or things to be implemented in SOFA. So you can see that. You can also check out the latest pull request. The idea will be it's going to be to take a bit of time to code together those days 2 and 3. That's for, is that, I don't know if it was like updated super recently, this one.
There is one more matrices that has been booked on
Okay.
3 p.m. slot.
Okay. Maybe I can like update here.
It's done. It's not
Okay.
It's updated.
Okay. There you see that again. Okay, and I think I'm going to add also something else, which is deprecations, which is another topic we wanted to have in the discussions. We could actually make separate tables, like if there is in parallel topics, but yeah, that will only depend on the things you are interested to discuss, and if you want to make some group on specific aspects, could be most welcome. There were Adrien maybe that wanted to come, but actually it's something I don't got a confirmation. I'm thinking about him just for the first bullet points about GPU computing. So those will be for day 2 and 3. So a few updates for SOFA, but we'll keep it super short. It's first about the consortium itself, like you know that as an open source framework, the purpose is to get like attracting people to work with us on SOFA and on the open source version of SOFA. Obviously, Neria, which is the investigator of the project, but still we do have people from South Korea with the Assad Medical Center, Fraunhofer, which is a research center also in Germany, which is still around. And we've got 2 others. So there were actually people from Florida and another partner, which is another partner from South Korea as well. That were 2 academics who left actually for financial reasons, not for non-interest of the open source. But we've got 2 additional members, which are really 2 companies. One of them you might know it, which is Insimo, a former spin-off of SOFA, which is now supporting us, and which its CEO Jeremy is now involved in the technical discussion. So I think it's gonna make also evolve the relationship and the contributions in the next months. And Caranx, that's you guys maybe I guess at Inriali you might be a bit more aware of, no? Okay, so it's a robotic company where Flavie is actually, so there is a PhD which is now now in between Inria and Caranx to work on the control of their soft robots, which I think it's I'm gonna say I need to remember the name of their robot, which is like a deployable tubes. They're going to work on the Cosserat beams. Flavie is not going to be there today, but she's going to be there tomorrow and maybe on Wednesday. We'll discuss that more. And more recently, donations as well. So the purpose is each time we get not in touch with a company, but we've got ready to work with a company, we always try to find ways either as contributions or as donations or partnership like memberships to make it official that they are working with SOFA. So that's what we do with the Anatoscope and another company related to Anatoscope. So we're making training sessions as well. That's things that are done in SOFA that are like attracting people actually currently a lot. And I've got another request a few yesterday or 2 days ago. A lot of those requests for training are coming from the robotics community recently, like quite massively. It's again reaching almost the 50% of the requests we're getting, and I think it contributes a lot actually to assist people in starting really with SOFA because as you might know, Stefan, or for the latest coming around, it's usually like a blocking point to get started with SOFA. And a few digits here to compare with the previous years. Last year, for the full year, it was a bit less than 60 participants, and we're like about 30 trainings already. So we should actually do more or less the same, even possibly a bit more compared to last year. So it's quite cool, and yeah, we're collaborating more and more with a program at INRIA which is dedicated to training on open source called INRIA Academy. All right. And for, I would say, ongoing operations, but it's a bit related to, I would say, like engineering contracts and so on. That's who is currently officially hired on SOFA, like dedicated on SOFA, 100%. There were 3 of them. Fred, who is online, Alex, which is next to me, and Robin, who is between the train and the building. Yeah, worked on 3 different topics. Fred on the modularization of the core of SOFA. For those who do not know that, Fred is ending his contract like in a few weeks, actually, even in a few days, because he got some days off to take. So ending his contract, and is also ending the project. So it's actually quite good news that we are coming to an end in the same time that the contract comes to an end. Which is not often the case, I would say, around around us at least. Alex, so on the modernization of the constraint pipeline and resolution, but currently it was the official topic of the project, but currently it's updating, modernizing the matrix format of within SOFA, if I may. If I say that correctly. And Robin, who is doing something a bit like SOFA Gym, as you guys know in Lille. But it's a platform which is supposed to become more generic, like not only reinforcement learning, actually currently not reinforcement learning at all, but it's in general machine learning, coupling machine learning algorithms with a physics-based simulation, so with SOFA. And the project is called Deep Physics. So those kind of contracts helped actually a lot in the previous months and years to get direct development in SOFA, a bit less, or I would say really less for Robin, who is working mostly in Python around SOFA. The release has been done a few weeks ago. He's going to talk later about that. And maybe just like news that we already talked about in the SOFA Dev meetings, but to make it official also in the technical committee. The fact that Guillaume is going to leave us, which means that we're going to, I see the scary face of some of you. So, hi Younes, you can take a seat. So, which means that we're not only we're going to, as Fred is ending his contract, we were planning to recruit a new Fred. We're going to have to recruit a new Guillaume as well, and this will be actually part of the things we could actually add that on the discussion topics, even if it's not really technical, but it's technical related, because we could actually redefine a bit what will do the engineers within the consortium, possibly not only maintenance, but also like implementing physics models and algorithms could be. That was not the profile of Guillaume, not really mine either, but that could become the new consortium. So, like, it's part of the moves. And to conclude here, just the criteria of success, like just again for you to know what is important for SOFA and the consortium, and when these objectives are actually met, what it means is that we're going to get more engineers working on SOFA. So it's like a loop. This works, more engineers. This works, more engineers, and 1, 2, 3, 4, 10, 20 engineers in SOFA. That's the objective. So obviously, I mean, the number of partners, whether they're academic or industrial, most importantly, the contributions. Even like if an industrial, is actually not paying in any way for SOFA, if he's contributing, that's actually already quite a lot of I would say a sign or an indicator for INRIA. Citations in papers and obviously products when it's a company, the involvement in technical committees and donations, and the logos down here. It's actually the contributors contributors to the code that are not necessarily people that are paying actually for SOFA. So that's the slide you actually see almost now at each SOFA week, and you'll carry on seeing it at each SOFA week and technical committee. It's what are the ways of contributions? So that's what I said, sharing code, obviously, models, algorithms in open source. We could discuss also tomorrow and after tomorrow the locations and the role of plugins, because we are noticing that more and more there is plugins around SOFA. But the problem is for those plugins to get known, it's quite complicated. People they need to check out a plugin on top of SOFA and so on. That remains still a bit of a struggle for external people. So I'm looking at you, especially Ines, because I'm thinking about Cosserat. And sometimes I'm just wondering if we should not, for some of those plugins, just get them back in SOFA, or at least putting them really, really close of SOFA. So like contribution of the codes, whether it's in SOFA or in open source plugins, helping people of the community, like on the forum, or improving the documentation. And on that, I think I see 3 people which are more or less here contributing to the documentation. Otherwise, for the rest of you, I think it's a bit more like a soft contribution, to say no contribution. But even if it's like minor contribution, it can help people, so never hesitate to contribute to that. Communication, obviously financial support and partnership, that's more for, let's say, institutions. And for the reminders about the locations, technical committees are as today, twice a year. There is for daily meetings, and it's also for the recording, but I'm saying that for people that do not know always the project, that you can have access to a daily messaging system like Gitter and accessing to all the dev community. The weekly meetings where you can really, anytime you have a question or you made a pull request and you want to make sure that it gets quickly accepted, you can just join one of the Wednesday morning, the SOFA dev meeting. We are discussing any topic, and we added some kind of a new rule where if something is actually tagged on GitHub with a tag which is written to be discussed basically at the SOFA dev meeting, that will be discussed in priority. That even if there is a lot of requests to be reviewed and so on, we want the weekly meetings to be a place for you to come, discuss shortly something, and that's it. And the forum, you know what is the forum now? You remember that it's not anymore on the website, but we moved all the forums on GitHub discussions, right? So do not hesitate to go there and ask the questions and help newcomers as well. Okay, that will be the, I would say, more interesting part for you instead of just listening. The roundtable to have an idea of the activity going around in SOFA. And for each of you, it's going to be like if you can just organize that always the same way, saying who you are, what you're doing, what's basically your position, what you worked on so far, and what you'll do in the next 6 months. That will be the structure for the feedback. I'll let these slides here. If you want to share anything, feel free to join the stream. Otherwise, we'll take notes at the same time when you're actually discussing. Okay. All right, I'll take the notes. Who wants to start? Let's take maybe just a regular round of let's do it this way. Okay.
My turn. I'm Alex Bilger, and I'm an engineer in the dev team at Lille. I worked on matrices in SOFA. I'm going to present it later in the morning. So I don't have a lot to say now. Sorry.
Maybe I remember you worked on like side projects like the.
Okay, I can talk about that.
You will not talk about in the
Sure. So there is a plugin for SOFA called SOFA GLFW, and it's basically another user interface based on GLFW, the library based on OpenGL. And on top of that, we have another plugin called I am GUI, so it's a user interface based on the library here. I am GUI, and it's a replacement for the Qt-based UI. It's quite it's an ongoing project, but it's quite advanced now, and it is usable. At least I use it every day. So you can grab it on GitHub and try it. Yeah. So you don't need Qt anymore.
And I think one of the objectives of this, it's completely like on the side because it's not your official topic of development.
Yes.
But that's something that we would make it possibly the default GUI of SOFA, not for this, not for this, or maybe not for this release, but actually for the next one, we would really like to make it the default one. So if you are really a lover of OpenSOFA in the old Qt version, let yourself know and let's discuss because you might like have a chagrin d'amour or something.
The new nicer.
So a remark or a thesis. For us in the room, if we talk loudly for just for the speaker, I mean for the microphone to get the sound properly. I'm sorry. So I don't know if we see that the same way, but I don't think so. It's going to be simpler. So if you think that simpler is nicer, it's going to be nicer. But like in the super sexiness, I wouldn't say so.
Oh.
I mean, it's way more modern. But I don't know. It's like maybe not like all easy buttons and so on. I don't know what you.
I don't know.
I was asking, is it more a matter of personal preference or?
No. It's. I think it's
the future of.
Yeah, no. It's modern UI. I think it's really close to what we've done now in.
But now it's so that you can, if you want, so you can personalize
And way more easily, I guess.
Quick question: what's the rationale behind it? Just the aesthetic, or
no, it's you don't need Qt anymore.
Yeah, so
that's the main
to get rid of the dependency,
Yes.
and GUI will be like.
And it's far easier to develop your GUI actually.
Based on this one, it's like a starting point which is already like not really specific one that wants to use SOFA, but for someone who wants to develop a dedicated UI to something else, it's going to be the perfect starting point without Qt, because Qt means that for us, maybe for like making research and so on, it's not a problem. But I've got the question a few months ago from engineers who wanted to build who are on the process of building their own company, and they were saying, okay, what's up with Qt? Do you know about how does it work to actually start a product based on SOFA? And if we need to include Qt somewhere, and it's like some not a problem, but it's a limitation for them, and they wanted to have. Okay, cool, merci. Oui, parfait, ouais, merci beaucoup. And so that's the most important point. That's the most important point raised by Alex. The second most important point is the Qt free. Second aspect, development possibility of new GUI based on this one. That will change a lot of things. Actually, so I don't see Jeremy, or I wasn't seeing Jeremy in the stream, but I don't know if he's around here. No, so
for example, there are Python bindings. It's not yet implemented with SOFA, but it's available on the internet, and we can imagine having to develop your own GUI with Python at the same time than your simulation.
And I think it will attract hopefully way more contributions than OpenSOFA was before, I mean, what so far with the GUI, with the Qt GUI, because it was so complicated to actually get to understand where what was what and the connect button stuff, and hopefully it will motivate people to really even contribute to it and maybe make some sexy, really super sexy, nice, or old-fashioned if you want to have it GUI based on this code. And I'll say that again, but really I think it will be an objective to get this GUI for the next release as the default GUI. So why I'm saying that is that if some of you are like maybe most of you are actually working with the master branch of SOFA, I'll guess we will actually very soon set it as an option, even maybe active by default. That would be something also to discuss. I'm gonna start adding things. Recruitment. A GUI was already on the list, maybe.
Yes.
Okay. So that would be nice to discuss also the timing of usage, so that us as developers we can really jump in the project, maybe add some fixes, because I guess since it has not been like used by hundreds of developers yet, there is maybe a few things to be found and typos and stuff like that. But I'm really super motivated. I was already saying that a few months ago, but I did not make the step. But super excited to get it to get it at least by default running.
I'm thinking about another advantage of this library, that it's way faster to render compared to the Qt app.
It's way
faster to render.
Okay.
Since we didn't uncouple the visualization from the simulation in SOFA, it's important.
Anything more? Okay, my turn then. So I'm Guillaume Parent. I guess everyone around me, maybe. So I'm working with Hugo for the consortium. I'm more in the technical stuff. Engineer for mostly around continuous integration and release management. So I'm basically responsible for the releases, for all the environment to be stable and simple as possible, as simple as possible to use for the users and also for the developers and researchers. I also work for the binaries generation, but not only for the SOFA binaries, but also for plugin binaries, something that is new since maybe latest or maybe 1 year. So I help the teams to generate binaries with their plugins. So my latest activity around continuous integration has been to clean stuff, basically. There is one, no, nothing very important to highlight. Basically cleaning, making everything smooth, and that's it for continuous integration. Most of my work was around release management. So of course the latest release, but also some work around, as I said, making it as simple as possible for the teams to generate binaries for their plugins. So for that, you may know that we use a lot the GitHub workflow with GitHub Actions. So I worked a lot around this GitHub Action workflows to provide workflows for the teams for their binaries. We did a crash test of all this at Robosoft last month. So it's still still ongoing work, but a lot of things have been done in the last months. So I guess it's taking the right direction, but there's still a lot to do. I did some first steps in two tasks. One is around the SOFA installer to provide or to dynamically provide the plugins that have been generated in remote repository. So the idea is to provide the users an installer for SOFA that is also installing plugins and plugins that are not in SOFA, but plugins that are in GFlows repository or anything. So first steps have been done, but still ongoing. And I also did some research around package management for dependency management, actually, with BCPKG and Conan. So as like for the other work, it's first steps, so there is still a lot to do, but it could be feasible to have all integrated dependency management in SOFA so that you don't have to worry about any dependency installation. Be very nice for the researchers specifically. And I guess that's it for my latest activity. Of course, there is a lot of SOFA NG integration, so it's my very latest, like today, activity, because Fred is terminating his contract. So all the work that has been done has to be integrated. So of course, this is something that have been done regularly, continuously, but now with the last steps of NG integration, there is also some cleaning to do. So this is my next, like in the next months, thing I will do, clean all the NG stuff so that it is well integrated in all our continuous delivery processes, so that SOFA can still be used as a SDK. I hope it's not broken. It should not be. And of course, the next release, so 22.6, that has to be generated next month with all the NG stuff in it. And another thing that should be added in this next release is the Python integration. So we want to embed Python libraries and interpreter directly in SOFA so that we don't have to tell people anymore that they have to install a specific version of Python because it's a pain. So we want to provide this in SOFA, and it will ease a lot all the tutorials and everything. And as Hugo said at the beginning of the meeting, I will end my contract after that. So at the end of summer, it will be mine. Even during summer, it will be my last days with Enria. And that's it for me.
So, I think the topic of release management, it's really something like you might see that, you know, for those who are in Robosoft or when you're going to conferences or when you are trying to share code. Like, I don't know if you already faced people that were like really no computer scientists at all. Maybe some roboticists are, and when you are trying to share your code and make them use it, it's like a huge pain because they need to compile stuff and they don't need how to, and they don't have, maybe there may be Windows, your Linux, and you did not get all the possibly Windows issues and so on. That's, I think, something we really need to make sure that for at least a short list of SOFA plus few plugins, make sure that this is easy to use, easy to install, easy to share, and like rock solid for and unlike Damien was suggesting a few days ago on the guitar, not for master branch, but really that just twice a year to have 2 rock solid versions, or even just one if you want to get back to 1 rock solid version, but so that people can really rely on that. And when we say rely on that, it's not only it's stable, I can use it, but I can install it like super easy. I'm talking with some mechanical engineers or mechanical researchers. They are as bad as I was years ago installing stuff. So basically unable to install anything. Even with the good instructions, you always get into some trap. And yeah, that would be really an objective for those to get those people using SOFA easily. That would be a perfect goal. So that's why I added it. Sorry. Also in some of the topics of discussions, it's for us maybe to discuss also, since Guillaume is leaving, to share some info, some where are we, and also what would be the wishes possibly for the next steps. If you have any questions on release management, also you can obviously either right now or later on discuss with me. Maybe Vlad, you can take the next.
Hi everyone. I'm Vladimir Fedakov. I'm with K11, robot-assisted surgery work. So for the most part, I represent let's say the user community, and as such, my goals are more or less self-oriented towards the project that I've been working on. That's a simulator for hysteroscopy. So for the past 6 years, I had been working on a, let's say, a framework that is based on SOFA, and essentially it's an integration of SOFA with third-party renderer, which is Philosophia. That's Filament. So together that thing is called Philosophia, and essentially it's just a decoupling of visual rendering and using an external visual renderer to have a nicer picture. For the next 6 months, I'm planning to work mostly on rupture and cutting simulation in SOFA. Hopefully, try to make something as general as possible, but yeah, we'll see how it goes. Yeah.
For that, we are awaiting a plane to not to crash, but to land on in Lille with the engineer who is working on that. Not for SOFA in general, but for his company, you know, Eric from Infintech 3D. If you don't mind, take the most of Eric while you've got command time. Like extract the most of the most information you can from him. There is actually several projects. We have been collaborating with Younes with a PhD in Germany who is looking at needle insertion. So again, it's not like tearing, but it's making some, or at least having some collision plus collision constraint and topology informations. Cutting, there is a PhD also in Strasbourg, in the team of Strasbourg, in the team of Robin, he's actually working on tearing. I was thinking about Younes because it's tearing from a needle which is inserted, simulating the possible really tearing and tearing of tissue while moving too intensively the needle. So again, that means topological changes here. So yeah, don't get stuck on that. It's something we would like to have actually.
Quite straightforward for me. I mean, I did some basic implementations using permissive stresses, although that's not an ideal case. Let's say for now, I just want to check if we exceed certain threshold. If yes, then we either delete or split the tetrahedron. But what I'm working on currently is okay. We actually did some changes in the mechanical object in the topology of the mechanical model, but we need to propagate this changes to the visual and the collision models. And for that, first we need to delete everything that is related to the way I see it. We need to delete everything that is related to this element, and then we need to patch up the void, this hole somehow along the surface of the mechanical model. So yeah, that's what I'm focusing on.
I think what we are really missing for the open source part, because I guess maybe not everything can be open source in your project. I don't know how it works.
Well, I'd love to. everything that's technical, everything that's not related to the simulation, I'd love to share it. Actually.
Yeah, that would be super nice because something I think which is really missing in the examples of so far is there is a few examples as you might have noticed, in the examples, component topology, topological modifiers. There is predefined topological changes where you can say, yeah, I want to have a cut here, a cut here. Okay, but it's not physically based.
Yeah, it's just based on some time.
Exactly.
I actually didn't change anything in the code. It's, as far as I remember, the whole thing is called user input data or something that you have in the topological change processor, and you just define it as yep, and then you check for misses, stresses.
That's what you do?
Yeah,
okay.
yeah, that's what I did.
Okay, but even
not
like simple, but maybe not. I mean, for some people, it's maybe not as simple as you could actually think of it. But having such an example of cutting based on mechanical informations, even if it's a Python script or anyway, would be really cool to share. And if you can, like, adding a video on it, and you're going to be a king of oil, as we say that in French. All right, no, but that would be really nice. And again, there's others working on the topic. This time, not connecting things, existing components, but really making themselves the physics that would generate in C++ the topological change without going through the topological change processor. Maybe in a more not sure efficient way, but we discussed. But keep us updated if you have some conclusion to share further to discussion with Eric. Not hesitate to share that. Okay, cool. Thanks. Thanks.
I have a question about filament. For me, it's a strong candidate to replace the 3D engine in software actually. So, can you tell me a bit more about your work with filament? And if you plan to release open source?
It's, as far as I remember, it's either on GitLab or Bitbucket. I'm not quite sure, but it's public for sure.
Oh yes.
And at the moment, it's a mess. I can't tell you. Yeah, but if you want, we can. Basically, what I do there is, for now, it's a little bit cheating, but I'm using two visual models. The one that is not represented in SOFA, but still can use barocentric mapping in SOFA. But what I want to do is basically move everything that is related to visuals to the filament part, including the mapping itself. And yeah, we have a mesh in filament that just represents the visual part. And we have everything else in SOFA, and every, like, depending on the frame rate of the visual loop, we just perform the update. So we don't call for the update of the mapping in between. That's a little bit, makes it a little bit more efficient because we don't render, we don't call updates on the mapping. And yeah, we just update the mesh that is used in filament and just render it. In terms of usage, I would say it's rather straightforward. The documentation is not that comprehensive, but the code itself is really, let's say, easy to understand and has a lot of inner information. So for me, it was a good candidate.
Thanks a lot. And maybe in the GUI, maybe you could anticipate a bit the GUI discussion of tomorrow, since you won't be there, and maybe I mean, because in GUI, I know GUI and rendering are two things, but
it's funny you mentioned Qt because I wanted to use the same thing for canvas components, because Qt cannot really render GUI components as a canvas in the scene. But what I want to have in the end is to either, what you have in Unity, essentially the same thing.
Yeah.
Kind of progress bars or some information to display. So in GUI can work quite great with that.
Thanks a lot, Vladimir. Stefan?
Hello. So I'm Stefan Destia. I'm a student in a master degree of applied mathematics. And I'm currently working on linear solver and making use of multi-threading inside of them. So the goal is to enhance the global performances of linear resolution and so forth.
Okay, I'm trying to find my note. There you go. Okay. And yeah, for what would be the next step? You wrote acceleration on GPU, right?
Yeah, for now I only have one solver on the GPU.
Mm-hmm.
So the next step will be find practical use for it, because as it is now, it's only worth it on simulations that have a lot of degree of freedom.
Mm-hmm.
And so it's not worth for on general simulation. So
Maybe it's could be the time also to ask, later on the coffee or whatever, if anyone has like a huge meshes, basically a high number of degrees of freedom in your simulation, and you are reaching a bit limits of performances that you're looking for, like to turn your head towards Stefan and saying, oh, maybe Stefan, you're my guy. And I'm thinking, like, for instance, Vlad, who is not always around, like not every week, aware of what's happening in SOFA, could be also a good application cases. Maybe also everything that you did, I think, is open source. If I'm correct. I mean, or will be.
It's not yet the case,
Not yet,
but
but-
it is planned.
Okay.
it's based on the toolkit. So
Implemented the same way. As far as I remember, you had something similar in software before, where you had like special classes or special templates for CUDA. I don't quite remember that thing, but I think it was something like
Yeah,
you could not really mix them up.
class specialization,
Yeah.
but this is not the same pattern
Oh,
here.
it's not the same here. So can it be like mixed with regular class specialization, regular templates like Vec3D, that sort of stuff?
it's not yet, but I think it will be done. But the thing is that it relies on the toolkit, and so can only use float or double type.
No.
But that, yeah, I think it's also an objective to get, I was thinking it was already the case, but working with our regular SOFA templates codes, like, getting any physics Vec3D and getting the solver only on CUDA. That, I'm not sure on how does the solver.
Yeah, actually,
work.
it can work with a CPU simulation or a GPU simulation.
Or already, right?
Yes,
Oh,
it's
oh.
independent.
In terms of benchmarking, how does it be against
It's-
multiprocessing, for instance?
Yeah, it's still in progress.
And yeah, but what you already noticed, I think, is the general conclusion is that it's not really worth it for low dimension and low dimension machines, and it's worth it so if you have
I'm struggling with that.
okay, that's why I'm saying that if you want to have like beta testers, could help with the publication stuff and so on. Okay, I won't say anything else because I think it's already a lot, especially for an internship. So I think it's right. Or maybe you are thinking about some other stuff you do at night on SOPA.
I'm also working on making use of multi-threading on the CPU inside SOPA.
Okay, it's more a generic. Okay, it's more a generic thinking of.
Yeah, it's more parallelize some things that are not yet parallelized.
Okay. Be interesting. Just so that you know, Jeremy, I mentioned him earlier, who is I think not online, but he was saying for the next objectives that you would like to be involved in, two things: GUI. That's why I'm turning towards you, Alex, That's one of the topic, and I was mentioning that for companies not Qt related, GUI are actually of interest, so they are interested. And the second one is performances, and that's why I'm saying that right now, if you want to have, and you know that already because he attended a few SOFA dev meetings, so Jeremy. But if you want to have also some feedbacks from industrial about the use of this of your software, could be interesting. If there is anything else later on coming up in your mind, just raise the hand. We can discuss that again. Tanguy?
Yes, so I'm Tanguy. I'm first year PhD student in the first, and I'm working with Christian and Olivier on design optimization soft robots. So I'm currently working on tutorial for design optimization of soft robots of parametric design. More like a Python tutorial. With on one side software simulation scenes for the evaluation of the design, and on the other side some evolutionary algorithm and model generation script based on GMesh. So it will be a tutorial. I'm working with postdoc from the lab, and so Stefan, and yeah, we plan to make it a tutorial.
And okay. So that's what you were mentioning that as a next step, right? You are currently and you will be working on those tutorials. Okay, and that's there will be a plugin coming with it, right?
I think the plugin maybe more tutorial.
Tutorial. Okay. Okay, thanks. It's 10:15. We are sharp on the clock. Now, just to cut a bit the roundtable and make it a bit less linear, we can maybe grab a coffee for how long? That's my slide. Okay.
Oh no, we only have 7 minutes.
Okay. Wait. Is that? I don't remember why.
Get out.
I'll get in and out and again, and there we are. So we can restart that in 5 minutes if you can on the computer escape and start again. Okay, so we can make a break for 15 minutes and then we'll carry on the round table, and it's gonna be the time to say hello for some of us.
Oh, quick question about the forum.
Yeah.
Are you planning to
Go ahead for the coffee and
Are you planning to move all the threads, all the topics from the old forum?
Yeah. So we'll keep, I think, the forum open on the website. As is now, it's actually now completely passive. There is no registration possible anymore and so on. And I think we'll keep that here because Google referenced it already where it is. And I think for the moment, I think we were
just split all the new.
I don't know, maybe, but it's just a question of putting the effort of making a script to export, import, and so on. We would be like 10 working in SOFA in general. We would do that for now. For the moment, maybe not. We'll see.
I guess it doesn't really matter whether you have to.
But it's just a question of cleanliness. It would be obviously nicer.
Yeah, from the user's perspective, it's also not quite clear. Should I go there or here?
Best is to Google. I think just to Google the question, and Google will give you a few things.
Oh, makes sense.
At least for the old form.
Every time I Google sofa, it gives me sofas.
Yeah.
Many sofas.
But that's a good question.
On va retourner pour.
Et quelqu'un me demande to remind you about what's going to come next. What's going to be next is so that we're in the roundtable, and then we're going to look at the roadmap contributions and like make the summary of what happened in the last 6 months regarding the roadmap itself. Right. And we were there. All right. So let's carry on. Everything is fine for you, Viola? Okay. Eulalie, let's go.
Yeah, so hi, my name is Eulalie Koulitz. I'm a junior at STC. Last 6 months, I've been mostly working on simulation of softwares. So I'm more a user than a developer. And I will continue to work on simulation for the next 6 months. So I don't have something interesting to report today.
Is there? Are you really considering yourself as more a user than a developer?
Currently,
Yeah. Okay. Currently, yes. Okay.
I'm still here to learn.
Okay.
I see some.
Okay. Cool. All right. Yeah, I was reading. I'm basically just making simulation right now. All right. Perfect. And as I said, let me just earlier, and the purpose is also to like take the time to discuss and share information together. If you want to connect to some guys doing something that could be of interest, and take this opportunity. Thanks, Eulalie. Olivier.
Hello, everyone. So I am Olivier Goury, I'm a researcher in the defrost team. So what can I say? So I still work on the model order reduction plugin. Right now it's more updates to it so that it works again. Because with the new updates so far, it got a bit deprecated. So, and we're gonna have some postdoc working on it also coming months.
A postdoc that we know, or
it's too early to say. We have hopes. I don't know if I can say. Maybe wait.
During the next coffee.
okay. 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 Cool. Okay. Update and okay. And that's so that would be rather for the future of for the next months of development. There could be a postdoc.
So in particular, we'll look at what happens in case of contacts and reduction in these cases when you have so that would be the application would be for simulation in surgery, and when you want to reduce the model of an organ in contact with other organs.
Okay.
Because for now the plugin is more used in robotics for a model that is actuated with, so you know the actuators, you know exactly how to deform the scenarios of how it will be deformed. But we haven't really dealt with the case where, for example, you have an organ in contact with other organs, and how do you generate a model, reduced version of the organ that is going to be accurate enough.
Can I have a question?
So sorry.
Can I have a question about that?
Yeah, definitely.
The thing is, last time I just had this discussion, and the question was, right now we are saying we are in the medical case, we want everything to be precise and everything. Why we are trying to reduce the other reduction, knowing that this can maybe bring some more errors.
Yeah, so
we are not simulating everything.
So the idea is that, let's say for example, in that specific application, it's a needle insertion in a liver. So you will not reduce the liver, you will be very accurate on the liver, but you will have on the surroundings an approximate model, but that is because you don't actually need to be
Is that already open source?
Yeah, it is
I
open
think
source.
so.
It's on GitHub.
Okay.
But it's very simple. Okay, it's basically one force field and one kind of reader that reads a file format that tells you which crease is valley or mountain. So that
Is that a usual format, or I mean?
yeah, so it's there are several formats, but it's one used format at least. It's called fold, as in folding. Yeah, so I could show you later just one simulation.
Yeah, definitely. Yeah.
Okay, so yeah, it's in collaboration with Dewey Monet, the artist who came for Harlem. Okay, and what can I say more? And maybe I can just say in the pipeline there is this order 2 constraint that I would like to look at chance few months coming, but we left at unfinished, unresolved state. So
you want to get back to?
I want to get back to it because we have an implementation, but it's not completely satisfactory. It has some strange behaviors in some cases, so it's not really usable as it stands. So I would like to resolve that so that we could try something new.
And both for the two, the two last points for SOFA origami and SOFA origami. So you because you said that in the what you did in the past, and that's what you wrote, not so mature yet. So do you want us to make the like a promo, or just just showing that on the marketplace already, or not yet? Because you want to improve things again.
Not quite yet.
Okay.
But it's I think it needs a little bit of cleanup.
Okay.
Soon, I think.
Okay.
Because
So
it's not
never state when you consider and never underestimate when you say, oh, I think it's okay, just poke us and we can add it on the marketplace. To get back to the topic I was mentioning earlier about the plugins and the allocations, to at least, even if they are not in SOFA or reference are as to be fetched with SOFA, at least to have them on the marketplace, online on the website. I think it's important. I mean, it gives them a bit of visibility.
Yeah, I think I'm waiting for maybe to do a small paper with Dewey.
Okay, cool.
Maybe not a super scientific paper with it,
but more.
I don't know yet. Actually, I'm questioning. I'm wondering what to do with it.
Okay.
But so when this will be done, for sure we can. More.
All right. Camille.
Yeah.
You're the next.
So
maybe you're the crocodile. Are you the alligator in the dock, or what?
Probably, yeah.
Okay.
I'm in the dock, so.
Okay, so you're the alligator.
Yeah.
Go ahead.
So yeah, my name is Camille Crepquin, and I'm a postdoc in the DevForce team as well. And basically, I'm working for a European project which is called SimCardioTest, which purpose is to let's say demonstrate the efficiency of simulation in the development of new treatments for heart diseases. And so in this context, I'm working on the simulation of pacemaker leads inside the heart. And so most of my work is dedicated to that, but for that I'm using the Cosserat model to simulate the lead. And so lately I've been developing a plastic version of the Cosserat model. So this is a bit on hold for the moment, which is what I mentioned in the document, that it's still experimental. But I'm doing verification work on that to strengthen the model, let's say. And what I'm working on, what I've been working on most recently is the adaptation of the interventional radiology controller from beam adapter to Cosserat. So I'm currently implementing that. It's not functional at the moment, but it should be quite soon, as a matter of weeks, probably.
With the same philosophy of having something deployable, or
yeah, the idea is to be able to use the controller to navigate coaxial instruments, typically like a guide wire and yeah. Okay. So this with the beam Cosserat.
Okay, you want to kill beam adapter, or what you? Okay, in Python, I guess, for the
well, I mean, at the moment, at least it's in Python.
Okay,
but
because I remember it was a discussion on beam adapter to say, let's simplify all the code of beam adapter and just keep the beams, like in Cosserat, just keeping just the beams and the mechanical model, and making the adaptivity part in Python to make it make also the code a bit simpler to read
and actually in the process I'm also updating the documentation of the beam adapter plugin, well, at least of the interventional radiology controller. Okay. So I've not committed anything yet, but while I'm passing the code, I'm putting additional comments.
Okay, cool.
The sub-side contribution. So yeah, I guess that is.
Okay, so continuing those two.
Yeah, well,
parts.
In the next month I'll keep working on the simulation of lead navigation, and so basically I'll try to finish as soon as possible the coaxial model for Cosserat beams, and then try to finish the work on the plastic version of the Cosserat.
May I add another bullet point in the next? That would be because I mean you made me work on that, so I think it's something we're going to discuss again. It's discussing how to test and validate models.
Yeah. Well, I mean that's part of what I'm
the
doing
unit
for the
test.
plastic. Yeah. Either via unit tests or scenes, but that's actually it's something UNES has been working a bit on too. Verification of the Cosserat models. Okay. But yes, you can add that.
Validation by verification process of the mechanical models. Okay. Thanks, Camille. Younes?
Hello, I'm Younes Adagoyo, and I'm postdoc in the first team.
Can you speak a bit louder, please?
I'm Yunusa Adagoyo, and I'm working in the first team. I'm postdoc in the first team. I'm working on the project Cosserat, the Cosserat project, where we are working on the Cosserat model, the Cosserat model for soft robot. And after I present what I did on that, I'm also working on the Robocop project, where we are developing a new plant, clearing plant. I'm postdoc, still postdoc. I'm working like postdoc in this project also. I also have some simulation that I'm sure them.
Okay, it's
in the next 6 months, I'm still the same thing.
So a cochlear implant, right? Because you are.
That's what I present last week.
Yeah, okay. That's been some time that I think. Right. In the report, it was written, latest working on Cosserat, future working on Cosserat. So that we see really, I mean, it's good, your focus, right?
Can you say we still have plan for Cosserat?
Okay, and what do you have an idea what would be like priorities for
the next like 3 weeks or 4 weeks we work on the dynamic part. say dynamic, but it will be very differential kinematics. To add that, and now we have the non-linear strength implementation. For example, that we had also some tests to just verify some analytical result. Then instead of giving us some examples and seeing, we use them like technical tests for the next implementation. Show that when we change, we still have this period.
And that's going to be, I guess, here in common with Camille.
Yeah, I'm doing this for the constant strain, and I'm doing it for the non-linear strain also. I can do it for the plastic. Same thing for the okay, doing this like a tutorial, then we can give the opportunity to our collaborators also to be able to use it. Okay. And we are working like I'm doing this last week, but that's what I'm doing to change to like have some tutorials step by step. Same for
to implement the Cosserat model. Okay.
One for using the SPD, another one not using SPD.
This definitely when we
are not part of
but when we definitely when you compare plugins with and without tutorials, like it really makes the difference for people to start working with your code. So I mean, just to motivate you working on those tutorials, it helps so much people that are you go on the GitHub and you see just SRC and maybe with luck an example folder. But when you see examples, tutorials, and possibly doc on top of that, it's like it gives another dimension to your plugin. So okay, cool. So tutorials for the Cosserat plugin. All right, Christian, you're next then.
Okay, so I wanted to just give some news or a different topic. So in the past there was we went to the RoboSoft conference. I think that was interesting to see how the soft robot community is now inside SOFA, and there is more and more people working on it. We saw several presentations showing results in SOFA. Even people we didn't know they were using SOFA, that was cool. In the news, I just had it was on Wednesday, that the CNRS will dedicate one engineer for 6 months on SOFA Gym, helping us to make the code of better quality and stuff.
Okay. So I don't know how much it could be related because you're gonna Romain has an extension as well for until is the engineer starting around the summer or because Romain is gonna, or at least your contract is for the moment until December.
Okay.
So that could be a nice covering, and we discussed that few. I mean, I know it's not something which is super urgent for Mimesis, but reinforcement learning is missing in deep physics. And that's what is in SOFA Gym for avoiding having thousands, like 2 projects in parallel on the same idea of coupling by stuff could be nice. If it's feasible, let's do it. If it's not.
So we just have to write, so we can discuss, and we have to write the program for the engineer for 6 months, but mostly it will be to I think, pass on the code, do some tutorial.
And is that related to CAT, sorry, in any way, or okay?
Another project that is starting is T-Rex, so Lali already told me about
But so you're officially on the project?
Okay. Yeah. So she's on the project for 5 months. So the idea is to start. So in T-Rex, it's a big project, big national project for the robotic community in France. And there are different axes, and each of these axes will have a material, new material. So humanoid, a new humanoid robot, medical robots, for instance, etc. And we are supposed to deliver digital twins of this. And SOFA is involved in at least 3, maybe 4 axes. So Ali is working on the first version of these simulators. And
when you say of these simulators, what does it mean? Because
so basically, for instance, the robot in Strasbourg for medical robotics, we do a digital twin of SOFA.
it means Eulalie is in contact with like possibly a lot of labs to get their digital twin in SOFA?
Yeah. Okay. So we are in contact. So today it's mostly on 3. We have 1 contact in Strasbourg for the medical, so surgical robotics. 1 contact in Besançon for the micro robotics. So the idea is to do a parallel robot and report. And the last is Nantes, where you have the former PhD student which is now in Nantes, and the goal is to do a XXL robotics. It's a cable robots, and we use Cosserat.
Okay. So and Besançon is that Femto, which is
Femto.
Okay.
There is only Femto.
Okay, and you said parallel gripper or parallel robot?
So it's a kind of parallel micro robot.
Yeah.
And they want to add a gripper on top of it.
Okay.
There is also, we are also organizing a summer school beginning of July. On the topic is deformation in robotics, and in general we are making a big effort towards like education on how to simulate deformation. I think it's important. Something new in the community. We have a big. I mean, today we are known for that, so it's a good opportunity for us. Another opportunity, I've been invited to the CSMA community, which is a national. So these people are working on structural mechanics, and you see this is the French community of structural mechanics, and they were interested by SOFA and by the work we have. So and I miss it, but frankly, this committee also have this ability to create new platforms, etc. And they are in the session of their colloquium. They have sessions dedicated to software. So unfortunately, I missed it, but I think it's interesting to see other people doing other software, and maybe there are opportunities. In the future, I think there is 2 points on which I would like to emphasize. There is the GUI. This is a topic where we were supposed to have an engineer, and we managed to find money for that. It's something really missing. I think it explains why STLib is not working today. Because the idea of STLib is it will work if we have a GUI that takes into account this system.
Okay, and we were when we were discussing about possible topics, if we got an engineer replacing possibly, I mean, take the next steps of Fred. There was a question of what could be the topic, and we made the distinction between a GUI for robotics and a GUI for SOFA only. For robotics, is there already like as Eulalie already started, or also some starting position that will be already that are already spotted for in the context of TRX? Because I think it was
Yeah, we could maybe yeah, it's not today dedicated to that, but we could maybe ask. So if we see, we can work on it. But,
I know mode was also interesting having that. So it does not need in the context of TRX. It could also be
yeah, there are, in the context of TRX, what we are trying to make is bridge between SOFA and Pinocchio,
yeah,
which is another library but for rigid robots, with Gazebo, which is the software used for digital twin robotics. So maybe this guy will work on that. Will work also on the GUI for SOFA. We have to see the person. The thing is that for now, TRX, everything is not, all the positions are not really open. Because I like some information from them. I will not go into too much detail, but I like this stuff. The other topic, so there is this GUI, which is for me an important topic. The other topic which is important is the general non-linear mappings in SOFA. So another way of presenting what Younes was talking about Cosserat. Cosserat, in fact, SOFA, the implementation of Cosserat is mostly a non-linear mapping. And when you have a computation of force or mass or inside under non-linear mappings, there is a lot of missing computation so far that we need to add. And I think it's important to focus on that.
But here it's going to be a six hands job, right? Because I think it's related to the also a bit to what you mentioned about the order to constraints, not directly. Okay, but at least it's linked with the API of matrices.
And I'm going to talk about it. Okay. But it's an important topic. We are missing information. We are using more and more these mappings. But and if we have that, we have all the terms. We could have a framework that is really.
Okay.
I'm finished.
Already a nice list. All right. And Robin, and then yeah, then go ahead.
So I'm Robin Gelbert. First time we see each other, so nice to meet you. So I'm the engineer in Nemesis team at Strasbourg, involved in the development of deep physics framework. So deep physics is our framework to interface deep learning and numerical simulations. I won't go through details for now because I will have just answer. So I have just maybe one great news to share is that 2 weeks ago I released the project. So thank you. And as Hugo said, I signed an extension for the next 6 months, so I'm able to stay work on 6 months.
So could be a really if could be a really good match because if we could have, it could be a topic of collaboration even in the future to share the same ideas.
And we plan to tackle this issue. So.
Yeah. But when I discussed that with Stefan, Stefan is in Oslo for 3 days here, but he was. So we discussed a bit about reinforcement learning with SOFA, and that's a topic of interest, but like not urgent, and therefore, if it's not urgent for him, but
to jump on, but we are going to have two projects on reinforcement learning.
Okay.
With Valentina.
Okay.
With capital insertion. And
which is really
long.
Exactly what the
work on reinforcement learning with robotics.
Okay. Okay.
And they will use the physics.
All right.
Can I ask just a quick question? It doesn't have anything to do with physics, right? With physics.
No.
It's just,
NVIDIA products.
no matter.
But that,
Because I was wondering, like, what's the purpose then?
yeah, that's in the naming of the project. I thought about it, but I said maybe people won't ask too many questions about that. You know, so far deep physics, so maybe no. But no, I mean, yeah, there is the physics always appearing, so we should make it clear. I'm just browsing.
Il y avait une question.
I'm sorry. Go ahead.
C'est long in robotics. The last that we work on.
Long is a PhD student in the team.
It's the first name.
Okay, which kind of robotics? So
I'm not really aware of the subject. But
It's the suite of all the next steps of what you started back with Adrien, the robotic needle insertion. So you would.
you say robotics, I think software.
No. It's really surgical robots for needle insertion. I'm just browsing everyone here to see if we covered, because since there is some missing guys, just to give you a word about them. Okay, and you already made the sorting. Okay. Just a word about partners in Assad Medical Center, which are maybe online, but not sure because I don't have that under the nose. But we've got a new technical contact with them, and they are working on navigation and implementation of interventional devices like catheters, guide wires, and balloon stent deployment. That's for you if you want to have a travel to South Korea, Camille. So that's the thing they are going to work on in the next 6 months, and even actually further, because that's the topic also of a related company that they are working on. Fred, so Frederic Roy is going to join also part of the team. So he's going to work also on these topics. We're going to I guess in the next SOFA week. So in 6 months, we're going to have more updates of where they are and what they're really aiming at. But they mentioned that they were interested in the coding task, improving the tutorials. I think for them to start, it's something important, and also for general topics, it's improving the performances of SOFA, especially in the case of contacts, so factorizing the contacts and that kind of things. But they are some kind of leveling up in SOFA for a few months now. A word about, so I already mentioned Jeremy for Insimo, so the technical contact also changed for Insimo. Before it was François Jourde, for the ones who know him. Now it's Jeremy Allard, for the few who know Jeremy. So Jeremy was involved for a long time around SOFA, and he's involved in the SOFA dev meetings, so he's willing to contribute also in the discussions there, but he was mostly interested in the two topics I mentioned before, GUI that we already discussed a bit, and performances that we discussed also a bit before. So there is ongoing discussions, especially on the Wednesdays, talking about multi-threading and GPUs and GPU computing and more generally linear solvers so far. And browsing for the one I know. So yeah, Flavie from Counts will be there tomorrow. Sorry, but she's working on the Cosserat plugin, and she will be working on the Cosserat plugin, but more, I guess, as a user and developing some control laws using the Cosserat plugin. And we've got also some updates from University of Florida with York Peters, who saw that we explained that they were implementing plastic deformation for EXA meshes for EXA linear elasticity. So that this should be almost ready. We could actually ask for maybe if it's possible to access that or merge that into the open source code base of SOFA. And a bit related to what Olivier said before, they are going to update also all their code with with the new changes in SOFA that are actually upcoming, especially for the next release. So that's about it. Maybe I just maybe forgot myself. What I did, I'm not doing much in SOFA, but what I did is improving like training sessions, slides, and so on. Working on the migration from the old forum that we discussed earlier together, Vlad, to GitHub discussions, helping people on GitHub discussions. And obviously it's part of my work, but I've been explicitly asked to like diffuse this kind of charge to a bit everyone in the community. Not only because it's going to save me time, but most importantly because it's the purpose of a community. I'm not, even if there is some role of community manager, it's important that it's not only up to me to answer on the GitHub discussions. Otherwise, it means people are going to wait for me like not a year, a week or 2 weeks or a month, and it's like very bad image for the project for people just keeping waiting for replies, especially when they are just struggling for compiling SOFA, and you're as good as I am for replying those things. Personally, I really like it because you get super positive feedback from the community, so I can only encourage you guys to do the same. And really more technical stuff. I'm working on the mass in SOFA. That's my lovely that's my lovely topic. I recently made a pull request on deleting the gravity from the nodes. It's open to discussions to get real like gravity force field instead of this shitty gravity in the node. It has huge advantage to get that in the node, but like it's to be open to be discussed. And I'm gonna work maybe also like merging diagonal mass and mesh matrix mass to keep only two masses, the uniform mass and the mesh matrix mass. There is a bit of a struggle for rigid cases that we're working with the diagonal mass, but otherwise like deleting diagonal mass and handling topological changes in the masses to make sure that everything is clean and working, especially with the callback. Now avoiding using the old API that we had before and now using the callbacks. You know that if you have data, if you want basically internal update of a component, if anything changes, it's supposed to be made now with using the callback. So that's if you have questions for that, also we could discuss that. So that's for the next step. There will be obviously making the transition with Guillaume leaving, Fred leaving, and myself making the job of 3. So that will be like obviously not possible, but over the summer, one of the important tasks we were hesitating to add it on the roadmap, but it's basically recruit people. So if you have good profiles, people ending contracts, or if you wanna like push friends that need a job and that could do the job, it could be possible. And again, it's the opportunity to rediscuss a bit the orientation of the consortium. Maybe not only doing CI and I think release management is key. We discussed that, but maybe we could also recruit more physics oriented people if it's what we think is important. And last word, it's going to be about conferences. There will be the summer, so it's going to be a bit calmer. Early July, there will be the conference. I'm losing the name. I should look at the agenda. It's CM something. Sorry. CMVH. No. There is VPH for that could be actually in September, October. Do you remember when it is, Kenny?
I think it's the first week of September.
First week. So they want to go there, but yeah, I'm a bit reluctant for 2 reasons. First, I will be alone at this moment against 3 right now, more or less with Fred and Guillaume. So leaving for a week might be a problem. There is also leaving for a week on a personal standpoint, and then taking the plane for other like ecological reasons. So I was hesitating, but if you guys think it's important to be there, I can definitely go there. And it's to make a presentation, tutorial, introduction to SOFA to the VPH community, so could be of interest. So we could rediscuss that maybe together.
Discuss it together.
Yeah.
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 Probably useful. I don't know in the community, like, is there interest in so far, real interest or not with this community VPH? Because for me the community is quite large.
Of VPH, you mean?
Yeah.
The community, part of community in VPH that could be of interest for us is maybe the like medical simulation community, but that might already know so far, I guess. Not sure, but maybe to be investigated could be. But yeah, there is the proposal. I'm supposed to reply by today, or actually by tomorrow at the end of the month, to apply for the workshop. So we could, if you can remind me to discuss that, between us three maybe. And I was referring to in July to a conference more related to the community you mentioned before, Christian. It's mechanics, the community of structural mechanics, actually mechanical simulation in general, which is called EMDC, and it's for biomechanical, I think. It will be in Glasgow in July. I'm going to take the exact same trains as we did before from London, but yeah, that was part of the identified conferences we wanted to be there. It will be the first time.
And to go by train at Porto.
I looked at it a bit. I'm a bit discouraged because we need to go through Biarritz and then we arrive in Spain. Okay. So yeah, that's about it. But I think that there will be a real phase of transition here for the consortium part, for the with Guillaume, with Fred, and so on, to make some kind of a new phase, to restart a new phase of project and recruitment. All right. Oh, all right. Sorry. Let's get back to the slides. That should be there. Still my slides here. And to conclude this roundtable, and then we are a bit ahead of, a bit in delay. We're 15 minutes delay, so I'm going to be very short on that. Updates from both Mimesis and Rainbow, which are two research teams at INRIA. Obviously machine learning, but we're going to talk about deep physics. I had two bullet points because that's on a scientific point, what they are interested in. Making these Newton solvers, so Newton-Raphson solvers for nonlinear problems to solve, providing an initial solution which is provided by a neural network. That's the reason why actually deep physics was started. And about mappings, creating mappings that could actually recover nonlinear deformations, even if you have like a linear model which is simulated on the physical part, but you would have a mapping that would make the rendering appear like as it was a nonlinear constitutive law through some neural networks as well. That was an idea of Stefan. So that's what they are looking for. Working on Caribou, there is still one PhD student working on that with at INRIA, and one at University of Luxembourg. There will be a short presentation on that as well, actually a video that Arnaud prepared. And they are
Arnaud live.
Cool. Nice to have you, Arnaud, with us. And it's actually the project that they are leading together. It's to couple SOFA and Phoenix to generate automatically from a weak form of equation described in Phoenix to get automatically a force field in SOFA. So if you want to have so I'm going to talk about the neo-Hookean, but it's already existing in Caribou. But if you want to have another constitutive law that you would like to write yourself, a more complicated one, you could have it this way, coupling SOFA and Phoenix. So I think for Quentin at Defrost, it could be very interesting to develop new mechanical materials like constitutive laws, especially some that are not existing in SOFA. That could be a good option for generating automatically C++ codes from that. Another topic is to get towards going towards automatic differentiation for especially for machine learning approaches. And a wish list, it's more a wish than a really technical topic that Mimesis is going to address. It's collision detection. Some guys in the Mimesis team are actually working on a dedicated detection pipeline that they have. But it's a bit specific to needles, and yeah, there was the question of maybe getting something more generic. and also having that modularized a bit in the idea of getting the constraint pipeline and constraint resolution modularized, so that we can implement new solvers, new method for constraints. It would be the same here for detection pipeline. No, I can't. Because I don't know. All what I said is that what I understood from Stefan, we can rediscuss that a bit, but I won't be able to give you much more details. And the two other INRIA teams that are working with so far are making, for the moment, small projects. First one at Epion, working on electromechanical heart. They had a blood flow model implemented as a constraint in SOFA, but it was not using the pipeline of constraint of SOFA. So that's what they are doing, really expressing the whole problem as constraint, using the constraint pipeline of SOFA. And Rainbow, they are willing to go towards using deep physics. So maybe remind me to provide you the email, and maybe send the first email to the researcher which is leading that in Rennes. And they should also work on the T-Rex project together.
Yeah, this is the fourth axis that we didn't talk about, which is manipulation.
Okay.
And haptic.
What are they going to do with deep physics? No, I'm not sure. No, I'm not sure. I know exactly what they're looking at, but I guess it's going to be close to reinforcement learning. I mean, it might be similar to what we discussed before with the reinforcement learning. So if you can add a coin to this topic, it could be. But yeah, we should start a further discussion in an email. Okay, that's it for the roundtable. Let's stop here. Either except if there is any other thing to be raised. Otherwise, we can make the tour of the topics that were actually planned 6 months ago for happening within the 6 months. So the roadmap V2206, but all the topics that should be included in the next release. Maybe we can start with Fred, since he's.
No, we start with Arno.
Arno, okay. Arno, then Fred, and then okay. Cool.
Maybe just remind the topics. It's the next
slide. So there were actually 6 topics. So SOFA Next Gen, the beams, matrix assembly, topology, SOFA AI, and SOFA plus Phoenix. A lot of them we already discussed already. So it's gonna be we're gonna get a bit more in detail of what has been done. And we'll see also if some of those topics will be for sure or not pursued in the next 6 months. So it's not going to be in the right order here, but let's start maybe with you, Arno. Can you hear us, Arno? Maybe you can take the lead.
Can anyone hear me?
Yeah, perfectly.
Yeah, we can hear you. Can you share your screen?
Yeah. Oh, that's my face. Okay. Can you see the presentation?
It's loading, but it seems to be loading fine. We'll tell you when it's appearing on the screen. I get it here.
Yeah, I get it here too, but it's not on the.
Still loading?
No. I mean, we have it everywhere on the computer, but just for the one which is displaying in the room, not yet for the moment. But
Interesting.
But you can already go on your presentation and go full screen, because I can see what you are actually displaying.
Sorry.
Okay. Yeah. On my end, I see perfectly the slide. We're just gonna wait for. Can you see also the what? Well, yeah, no, you can't see what we do see, but.
Give me a minute. Options. Let's do this one.
Avec le navigateur.
Oh, come on.
It could have been
Okay, let's forget it. Go ahead, start. We will
Good.
hear.
And can you see that, guys, on the if you're connected, and are you recording? It's, yeah, it's right.
You tell me when to start.
Yeah. In here, really a few seconds.
No problem.
Perfect. Go ahead.
Hi everyone. So today I'm going to talk about the new Sonix plugin we want to release. So Sonix stands for SOFA plus Phoenix. So actually we try to interface Phoenix software with SOFA for advanced constitutive models. So for this work, it's mainly coming from a Phoenix part in Luxembourg. So myself, Jack Hale, and also Stéphane Bordas, and also interfacing with the Mimesis team in Strasbourg. So with Sidati, Jean-Nicolas, and also Stéphane Cotin. So the motivation of this work is that in hyperelasticity, it's usually quite difficult to obtain the stress tensor and also the compliance matrix. It could be easily done for example, Saint-Venant-Kirchhoff material. But when you come to more complicated laws, such as Ozapfel-Ogden, it's getting quite tedious to get those derivatives. So we wanted to use the Phoenix software. Phoenix is divided in three parts. So you have a part when you write your weak formulation in a UFL. So UFL is really close to Python language. Then you compile this Python code using FFCX. Then you solve your finite element problem with Dolphin X. So it's actually quite straightforward to implement such a problem. For example, you can define your trial function or your test function, and then compiling some inner product. So I will not go too deep in a finite element method, but it's quite something we have to do often. So Phoenix is a great tool because it's allowed to do automatic differentiation. This removes all the tedious and error-prone manual differentiation steps, and it's also operating at the variational level. So for example, when you want to define in hyperelasticity your energy, so you're defining here your strain density energy, then you can just define it likewise, and then computing the derivative with just this operator, derivative, and you can precise in which direction. Then we come to FFCX. So all the Python script we wrote before, we can just use a command line FFCX our files, and then it will generate a big C file and a header, which contains all the operations to compute the necessity tensors, and yeah, also. So I will precise a bit later what we are talking about. And then usually with Dolphin X is catching all this code and using it to solve the problem. And what we want to do is replace Dolphin by SOFA. So practically how it's done. So in SOFA Caribou, so also in SOFA, I think we have some force field. In the force field, we have two main functions: add force to compute the residual, and add k to matrix to compute our big stiffness matrix. To do that, we loop through every element. In every element, we are looking for the ghost node. Then we compute the second Piola-Kirchhoff tensor and also the compliance matrix to obtain the residual and also the stiffness matrix. What we can do now with Phoenix is that we are only looping through the elements. We just use the C code we have, and we are just gonna assemble our stiffness matrix and our global residual. So it's really beneficial because we don't need to have an expression of second pillar Kirchhoff and also the compliance matrix, and we do not need to calculate any shape functions or take into account the geometry of our elements. So since the last SOFA week, we moved our small repository into Caribou in a small Phoenix feature branch, and we are working on merging it with the main branch. We made some tests to see if our calculations were in agreement with SOFA Caribou, and we found out that for tetrahedron linear, quadratic, and also hexahedron linear, for Saint-Venant-Kirchhoff and Neo-Hook, we are really close. I mean, we are down to machine precision accuracy. We also implemented the quadratic hexahedron. They are still slightly off, but it's really, I mean, it's really small error. It's mainly coming because the elements definition are different from Phoenix and SOFA, but it's still under investigation, and I think we're gonna soon come down to machine precision too. We also validated the non-existing material model in SOFA Caribou with FEBio. So for instance, we implemented Mooney-Rivlin, which was not in SOFA Caribou, and we compare it with FEBio. We also implemented a really complicated material model, like the first I show on the first slide. So it's Hozapel-Ogden anisotropic with 18 variants. And we have a small scene with a liver surgery, so you can actually grab a tool and have some contact with the liver. And we also worked on generalizing the Phoenix material. So it means that the syntax will be the following. We define just a Phoenix material. We precise on which elements we are operating. Then we give our parameters. So for Saint-Venant-Kirchhoff, it's the Young modulus and Poisson ratio. Then we give the name of the material. And we also implemented already a few unit tests. And we already quite have an advanced draft of a scientific paper. For the further development, so we plan to merge our branch with the master Caribou branch. So once we, let's say, carry on all the cleanup operations, we plan to give better documentation because for the moment, everything is developed by Sidati and I. So it's actually quite difficult now to get into it. Now adding a new material still involves some operation at the C++ level. So a lot of copy paste are still involved. So we are working on this to avoid the user to go too deep in the C++. And also one goal is that in the Phoenix material, you give the material name, but if it's not implemented, it's not gonna answer anything. So we are working on giving directly the path of the C code that has been generated. But this will require quite a lot of work because from Python you need to call the compiler to compile on the fly the C code. So it's still quite a lot of work, and we still need more CI and CD tests to ensure the stability and compatibility with Phoenix and the SOFA master branch. But the compatibility with SOFA master branch, it's quite already ensured with the Caribou plugin. So we have to take care of the Phoenix branch. And we could also go into more complex elements if it's a need from SOFA. With Stéphane Cotin, we discussed maybe the shells, but we could also go into prism or segments or whatever complex elements you want. And also in the upcoming 6 months, we are hoping to have first user and first test to give us some feedback on if it's user-friendly enough or not. Thank you, and if you have any questions, please let me know or contact us on the GitHub.
Thanks a lot, Arnaud. It's really nice presentation. Is there any question?
Yeah, I have two questions. So one question and one remark.
Yeah.
The first question is, you mentioned that you are using a Q1 element.
Yeah.
So is it in 2D or in 3D?
In 3D, sorry, I didn't precise it, but it's a 3D hexahedron. All the elements I showed were in 3D.
And do you have like membrane elements, or is it possible to have?
Sorry, which element?
Membrane.
It's implemented in Phoenix in a plugin, and it was a need also from Stéphane Cotin maybe to go into those elements, but yeah, it should be possible.
My second point was more remark. I think that there will be also a lot of interest of your work for the soft robotic community. There was last year there was a paper developed in the community where they did a framework and a database of different materials that are used in soft robotics. It's a paper from the group of Fernando Bello. And they have put all the data in open. So they did a lot of tests. They managed to fit some different material. And we could, it could be a very nice, I think, opportunity to answer their database with the corresponding simulation.
Yeah. Do you remember the link of the name? It was Younes. I don't remember.
No, it's K.
Okay.
But I can give you. Yeah, I can find.
Yeah, if you forward me the link, I'll be glad to check with them maybe.
Because you have all the data of their test, and they manage to fit so different constitutive law. So you just have to re-implement basically the value they have found and verify that what you have in simulation corresponds to their measurements. I think that would be very good.
Yeah, and the connection could work really nicely between what you did, because then I guess they might have a way of expressing the materials which is quite standardized for their purpose, and then going from there to the translation for the Phoenix writing in the
And basically, if you want to, you also if I don't know if you want to publish this work, but this is a way also of having a validation with like experimental validation without doing it. You just have to grab all the data.
Yeah, it could be a nice reinforcement for the paper.
And also in terms of publication, I think if you connect that to the soft robotics community, could be also like a lot of people using it, citing it, and yeah, could be. I mean, being at the bridge here between the two communities could be really.
Camille, you have put the link?
Yeah, I sent a link. I don't know if it's a paper. It's called Toward a Common Framework and Database of Materials for Software.
I get it as well, but I get the paper, but I don't get the. Yeah, that's the link I have as well, but.
Oh, there is no paper on this.
Yeah, I can't find the.
There is a PDF download option. I downloaded the paper from the link I sent.
We'll find that. Yeah, in the next minutes. We'll send anyway. We'll send that to you, Arnaud.
Thank you.
Yeah, it could be really. It means it's a whole community that could directly grab the website, selecting the material on the website that we are talking about, selecting the material that they are looking for to use for their robot, depending on the material they used. You know, it makes the bridge between you tell what kind of silicon you use, what is the brand, what is the type of silicon you used, and then it gives you exactly it makes the link towards a mechanical constitutive law that you can select. And it could be nice to have that connected to what you said.
Yeah.
Is there any other question for Arnaud? Yeah.
I don't understand the difference between Phoenix and like differential simulation.
Yeah, so Phoenix, it's I can let you introduce with the keywords, Arnaud, what is basically Phoenix and.
I didn't hear the question. I think the speaker was a bit far.
How to compare? I mean, what's the position of Phoenix compared to differentiable simulators and so on?
Yeah. So compared, for example, with Ajax or those kind of or SimPy, for example.
Yeah.
So that's I'm not an expert with, but from what I understood is that with Phoenix we are working really on the variational level. So we are only using the chain rule. Let's say we're using the real definition. Some others could use some, for example, some statistics approach. So I mean, from what has been guaranteed to me from the Phoenix community is that it was accurate, at least the automatic differentiation. So that's the only thing I could tell about.
And the fact, yeah, it's just that Phoenix, the way so the Phoenix works is that it makes automatically this differentiation for you, but it was not made, I think, really at the beginning to get a differentiable simulator. But by design, it can offer that since.
I mean, originally it has been made by mathematicians, so they are not really a mechanics community, but it has been widely used now for mechanics problem with the finite element method. And it's really, I mean, for us, like you see, it's 4 lines. For us, we define just the energy, and then we just use the derivative keyword, and that can give you really easily those vectors and tensors we are really needed in mechanics.
Thanks. Is there any other question you want to ask something?
I have a question,
Yeah.
Arnaud.
Yes.
How your work with Phoenix depends on Caribou and not only on SOFA itself?
I think for that you can actually, if you go full screen, Arnaud,
Oh yeah, sorry.
you can see that on the bottom right. The way Caribou works, it defines that if it's a hyperelastic material, it will automatically, it will just request, it will ask you, so you have elasticity, sorry, force field, and your material law. And what is inside the material law is just the energy functions and that you need to define there. And it's really close to what was written down there. So if you're able from Phoenix to give that to the Caribou material, then the computation.
My question is, why do you need Caribou and not?
So to answer that is at first we developed it using fully SOFA, but we wanted to validate with quadratic elements, and as far as I know, they were not available in SOFA, so you don't have a quadratic tetrahedron or quadratic hexahedron. And in Caribou, it was already implemented, and also the way the force field is built in Caribou was really straightforward for us because it's really close to the finite element method. You build your tensors one after one, you go through the ghost node, so it was really nice to interface. But we could actually just use pure SOFA without passing by Caribou.
Okay, thanks.
Thank you.
Any other question? I don't see some, so I'm gonna just ask for. You mentioned validation, and I know there is some manufactured solution as well for in the Caribou plugin. I think what could really be a huge plus for both the plugin, your work, so Sonics basically, and also for SOFA directly. It's to get some kind of short. So if there is a paper about that, it could be directly the paper, and or at least a report mentioning that the validation results are saved somewhere, and that people can actually refer to that document. It's one of the topics we discussed with several partners already. It's people whether they are academics or industrial, sometimes they need to trust SOFA, and if they never used SOFA before, they are willing to get some documents where they can refer to it and say either in the proposal or for their own like safetiness, they want to check and investigate that SOFA is providing meaningful results and validated results. So that kind of report / publication, whether it's one or the other, would be really a plus. So I think I remember there is a publication ongoing, Arnaud, right?
Yeah, so like you mentioned, yeah, we also, so I didn't precise it, but we validated our result with the manufactured solution. And one goal that we discussed maybe is that actually we could let the users try their own material model and have a way to verify it every time, for example, using a manufactured solution or a cantilever beam problem. Every time a new user want to implement a material model, he can use it with Phoenix, and then we can validate it every time quite automatically. And then, yeah, let them see, I mean, after do a pull request to see if we can put it, include it in the plugin.
Okay, I have two other questions. It's how much copy paste it was requiring. You mentioned that there were a bit basically of handmade changes in the code. Can you really super roughly say how much work it takes, how long it takes you to do that, and so on?
So we worked with Sidati on kinda do a template of the material models. So every time, basically, you just need if you use a material model that didn't, I mean, that required new material parameter. For example, if it's something different from Young modulus and Poisson ratio, you need to add those parameters manually in the force field, so in the C++ code, but you just do it once. And also you need to do some copy paste of the function in the C file, but it's usually templated. I mean, I think you copy paste maybe for the Ogden material, maybe you need to copy paste 50 lines. I mean, I did it in less than 5 minutes, but it's still tedious to go in the C++. I mean, asking a user to go in the C++. The goal was fully to avoid them to go into the C++ to tweak something. So that was really the goal, to go really into Python, and that the users don't have to take care of this.
And how much effort, you mentioned shell implementation, how much effort do you think it would actually require? Because it is of interest of several people in the community to get robust and validated actually shell model, because
So Phoenix is relying on Basics. So Basics also, it's part of Phoenix. So they developed quite a lot of different elements, but they didn't develop shells. So Jack Hale, with the one I'm working with in Luxembourg, has developed a plugin for this, and I have to ask him if it's really difficult or not to have it in so far. I think we spoke briefly about that, and he told me it was doable without, let's say, without really titanic effort. He told me it could be done.
So the link has been given. I don't know if you noticed by Christian for the last. I think is the real website, because there is a GitHub for the material for soft robotics and a website. If you go on the last link, it's the full website information. So
Okay, I'm gonna copy paste this one and check it online.
Database. And for the next steps for you, it's if I remember correctly, it's like making I mean checking it was the Q2, right, case.
Yeah, in Q2 we still have some differences that we need to see where it's coming from. I mean, even if the elements are different, I mean the solution is close, but Jack wants to investigate deeper into this.
Okay. And they were then making more automatic the process, as we mentioned, getting the first users and coupling with and I added to what you wrote, the coupling with the material database for soft robotics, and really it could have a really nice impact on this one. Okay, cool. Thanks a lot. Thanks a lot, Arnaud. Yeah.
Thank you, and if you have any questions, just email me or go in the GitHub discussion. We are replying quite fast.
Cool. And it means that we should see. I mean, we should have some updates also from you in the next month, right? Do you have already an end date for your PhD, or?
Should be October, September. Yeah, I didn't put it as bullet point, but write my thesis is also one of the main goals.
Okay. Okay. Right. Okay. I don't know if you will be able to make it, but it would be if not, it would be a pity for us. But to get an update later on, maybe Sidati will be able also to do that whether you cannot attend. But for the SOFA week at the end of the year, it could be really cool to have a nice update of everything you presented. But Nice.
And also, once the paper will be released, you will be notified. And so, yeah, I think you will have some news from me.
Cool. Thanks a lot, Arnaud.
Thank you all. Have a nice day.
Bye-bye. So yeah, next one is Fred, all right? Fred, are you with us?
Can you hear me?
Yes, we can hear you.
Not that much, or I mean, it's okay.
No, it's fine.
Okay. You did answer nicely, so yes. Okay, so should you share the PDF or should I share my screen?
Go ahead with sharing.
Okay. Partager screen. Yes. Share. Okay. No, this is agenda. It's not good. Okay, so let's see. View full screen. Okay, is it okay now? Can you see the presentation?
Yes. End of the road.
Yes. Yeah. That's almost philosophical. So yes, I will present the end of the project and the task SOFA-NG, which started now a long time ago. So I always put this link is state of the project. So it started with an issue on GitHub, and everything should be marked here, so you can see all the history of the project from where we started, from where we wanted to go, and almost all the related PRs.
Fred?
Yes.
Just I forgot as an introduction. These guys will affect every one of you. What will be presented here will necessarily affect you, not always in the best sense you would like to I mean, on your personal efforts that you'll have to do, but it will change SOFA, really change SOFA, the core of SOFA. So you'll have to pay a bit of attention here. Yeah, go ahead, Fred.
But I guess, I mean, it's been like 2 or 3 STCs, even 4 maybe. We are seeing that, so I guess now people are aware of that fact that yes, this is important for you to follow and maybe to use it now, but I will say it later. So just a brief recap what we want, what we will be able to do with the SOFA-NG, what we wanted to achieve. Actually, it was to have the same syntax for the same place for all the syntaxes we are using in SOFA, so in XML, Python 3, C++, and maybe something else. So how we sorted the components is according to their nature and their features. So for example, for the box array, so a lot of people are using box array. Instead of being in the SOFA kernel modules, SOFA engine, I think, now you have to use what we call the SOFA.component, where all the components are stored. And after that in engine, because it's an engine. So all the engines are in the engine. And we created another subcategories. It's like all the engines who are selecting stuff. So all the array, actually, the region of interest engines. So in your XML file, if you are using XML, you will want to load the plugin called, or the module called sofa.component.engine.select. If you are using Python 3, I think in Lille you are more in Python 3, you just do import sofa.component.engine.select. So it's almost the same name, actually. It's like XML and Python 3. And while you are doing a C++, I mean, pure development, if you want to use, I mean, or extend the box array, you just have to include the same syntax like sofa/component/engine/select/box array. And the namespace follows also the path. What we wanted also to do is like, maybe not everybody wants to know where the components are, the precise location of the component. So if you don't want to bother, you say, I want an engine. I don't know where is it, but still I want the engines. If you do sofa.component.engine and that's it, you will load all the engines. I mean, all the modules are related to the engines. And if you really don't want to care about the number of plugins you want to load, but just you say, okay, I'm using a lot of components. I don't want to care about audio, silver and stuff. You just do require plugins for that component. It will load all the components of SOFA. So it's not very efficient at the startup, but at least you don't really have to bother about what you want to load. So that's a nice feature, I think. So before the old modules and the SOFA-NG modules, what? Yes.
Is there any way to know easily, like what do you, for the user, for the basic user?
Where things moved?
Yeah, but just to.
Yeah, but that's what I wanted. I will show you that it was in the to-do stuff. Here you see the last bullet points.
Yeah.
I need to do a graph of where it was before and where it will be after. So yeah. So
Christian is shaking when he's seeing the to-do. He's shaking.
Yeah, the fast forward. Yeah, but I mean, I want to do a nice graph to put on the website and stuff. I didn't want to do a shitty graph for that. So I want to do a nice one to put on the SOFA website. And actually, I put it after. But when you are using the old modules, CMake modules, it will warn you as this modules has been sorted into this new SOFA-NG module. So you already have some hints where it is now, but you will see later. So for now, for the transition between the old modules and the SOFA-NG modules, we wanted to do it as painless as possible, even if it will be still pain, but at least possible. So what it will induce to port to the new module is like to change the path, as you could see before, like before Bexora was in Sofa engine/Cosserat. I have to use
almost good names. It was called Sofa Engine.
Well, this one, yeah, I should have used Mesh Matrix Math. Much more, would have been much more obvious to why to use Sofa Engine actually. But. So anyway, so you have to change the path and the namespace, but this is quite easy to do. I will show you how I did for this kind of stuff. But there is 3 cases of where the transition layers will not work. It's like when people didn't set what they are using. So for example, a lot of people are using, I don't know, triangle set topology container. But somewhere else, some people were using a tetrahedron set topology container. So in that case, you could use triangle set topology container because tetrahedron is using triangle set topology containers. But the transition is not doing this kind of stuff. So this will break. If you are not using exactly the file you need, it will break. But this case is easy to fix. The second one, and this is a drawback from C++, you cannot do. If you do forward declaration, like to optimize the building time, you cannot. In the transition layer, I'm already using forward declaration, so you cannot do twice forward declaration. So if you are using forward declaration in your header file, it will break. You will say, it's already done before. I don't think a lot of people are using forward declaration, so I think this case won't be a problem though. And the third one is for like a template specialization. Like it's mostly, for example, for SOFA-CUDA and multi-threading. And SOFA-CUDA was just using, for example, mechanical object, and is maybe doing a specialization for CUDA types, or CUDA vector 3 or something like that. And you cannot do a specialization with aliases, because in the transition I'm using aliases, but you cannot specialize a class from its alias. So this is a drawback also for the C++. The same, I don't think there is a lot of cases of people doing specialization for certain type of templates, but can happen. So this is not possible to handle with the transition layer. So be aware that if you do something out of the road, let's say, you will have some problem. It's not difficult to fix, but you will have problem. So you can see here the list of the new modules in the SOFA-NG, but you should be aware because this list was almost designed like 1 or 2 STCs ago. So you can see in that list, it's quite straightforward. In animation loop, you have what? Animation loop. In collision, you have all the collision stuff, etc. One or two a bit tricky. Well, could be a mechanical load, maybe. So mechanical would be like torsion or stretching or pressure, something like that. So it's what we called before, I mean, still called actually so far external forces. After that, I think all the others are quite straightforward. I mean, in my mind, but maybe not for you, but at least for the SOFA core developers it was obvious. After that, so these are, let's say, the main categories, but inside each categories there is subcategories. So for example, for collision, there will be two categories like detection and response, which makes sense for collision, and etc. So in collision detection, there will be also another subcategories like intersection and algorithm, and response is contact. So yeah, so you can see that there is some subcategories. So I understand the need that we should have a complete, expensive list of all the available modules. So that's why I put to-do things to do. You can see already the list, but it's not really visible on the from iPad. I put the link here. So if you are if you want to see, you can go to that the line to that link, and you will have all the categories we can all the modules you can load into SOFA. So the transition was split into two categories, let's say, of files. So we need to do some modification for the CMake. So the old modules CMake now are just redirecting to the new ones. So if you, for example, you enable SOFA Engine, let's say, if you compare with Box Array, it will warn you all the stuff inside SOFA Engine has been moved to sofa.component.engine.select, and etc. etc. And in that slide, you can see for SOFA Simple FM, it will redirect you to FM and Elastic and diffusion. Well, this was a bit weird for me to have diffusion to SOFA Simple FM. So you can see already that SOFA NG was needed. And also we have to take care, and Guillaume is really aware of that. Is like we have to take care that the normal CMake files are correct, but also the files needed for the out of tree compilation, the SDK, let's say. Because when I'm doing my test, I'm not really using the installation part, so we can work perfectly. But if ones are just using the installation part of SOFA, the SDK, let's say, it's not the same in CMake files. So sometimes I forgot to add some lines and stuff. So we have to take care that the SDK files are correct as well. For the C++, it's a bit almost the same template. Is like the old headers are redirecting to the new location. So you can see, for example, the Hexahedron FM force field, which was located, I think, in SOFA something FM, I guess. And so you can see both. The first line is to redirect directly to the good path. Second line, which will be incremented in for the release, is to warn the user while compiling. So you will say, you should not use this path anymore. You should use SOFA/component/solid-mechanics, etc., etc. And after that, you have the namespace. It was the old namespace from Hexahedron FM force field, was inside SOFA component force field only. And now you can see there is a new force field. So this creates an alias, like I said before. So it's the same object, the same definition, let's say, but in another namespace. So it's almost the same as the real object, but sometimes you cannot do the same. Like I said before, you cannot specialize. For example, in that case, you cannot specialize the SOFA.component .force field .hexahedron force field. For example, if you are using this header. So this usually works well, but sometimes, yeah, like for example, for SOFA CUDA, I was obliged to directly use the new path and new namespaces. And for 2006, or maybe 7, I don't know, but let's say 06. Some pairs, I mean, a lot of pairs have been done to integrate all the SOFA NG modification. I've done one PR like to port all the SOFA code base to SOFA NG itself. Before, it was made on purpose, but I was letting the old includes to see if my compatibility layers was working. But for me, at the end, for the release, I mean, there should be not any deprecated warning when you are compiling. So that's why I wanted to have all the good namespaces and all the good headers into the compilation. So I've done a quite big PR to fix all that. It's not. I don't think it was merged yet, but I hope hopefully soon. I've done some plugins as well. Almost all, not almost. I think all the ones enabled on the CI. I don't think I did the PR, but my branch is already. And like I said, Guillaume is a watchdog for the installation files. So I'm counting on you, Guillaume. And as a side note, thanks to Alex, who did a nice utility, is to convert your XML file. Sorry for the Python guys, but how to convert your XML files, your scene files. We are still using the old required plugin, SOFA Simple FM or SOFA MISC collision, I don't know. And we will correctly find all the needed new modules for the required plugins. So it was a nice add.
It's a script or?
Alex, I think you know more than me. I think it was a C++ project, no?
It is a C++ application.
Yeah.
But you're
Yeah, because to use to have the what's the name? Not component change or something like that. No, you are using using the warning of the send checking to get the lines, no?
No, actually. So it loads the simulation, and based on the base object, you can get the module from the base object.
Yeah. Module, yeah, the macro module. Yes. Right, module target module for target name. I don't remember. Yeah, that's true. And okay, should I continue?
Yeah, go ahead.
And I think it's the last slide. So as always, there is still some polish to do. So I want really to test most, I mean, as much as possible to have the least how to say it, problematic release as possible. So that's why I'm counting on you guys to already use the master branch for testing this transition layer and the code itself. So don't hesitate to make issues or PR. I know that what's his name, Paul from Mimesis did 2 or 3 on Facuda, so it was really useful. So try to make it break, and we'll try to fix it as soon as possible before the release. And as a last note, some stuff was still not dispatched in the new architecture. So some was like some components, I don't know why it was here, like the gravity, I guess Hugo will maybe tell you more about that, or maybe he already said some stuff before, but maybe, I don't know if Hugo, you will tell us more about that.
Yeah,
and there was another.
No, not right now, but we discussed that a bit before.
Okay. After that, there was a pause on event component, which was pausing if you wanted to pause the simulation if there was a collision, which is a bit weird. I mean, there is some stuff, weird stuff like that. So I guess will be moved to deprecated state or remove state. I don't know. The second one is we have to decide about that because it's a call it a meta component, just a composite of 2 components. So box if springs force field is just a box array, and with the output of the box array creates springs using Steve springs force field. So you couldn't put, for example, you couldn't put to be put into the spring component because it needs box array, so there is a dependency problem. So maybe I'm thinking to do a sofa.meta component or something like that. I don't know. So we still have to discuss about that. And the last one is sofa haptics and sofa validation. Need to be also sofa energized. So for sofa haptics, I guess it will be useful to do a haptic category. But for sofa validation, maybe to dispatch it into existing modules. So we'll see. But this is really like the last one, so it's not that difficult to do. So I'm not scared about doing that. And to finish, I mean, I finished for the SONG part, but unfortunately, Hugo forgot me for the roundtable. So he didn't, he already forgot me, even if I left for Korea. But and so for me, so I did like 90% of my time was SOFA-NG and cleaning and stuff like that, CMake, reviews. And also I've done some, let's say, research, not research, but searching for the rendering problem in SOFA. So I've done some investigation with Filament, like you guys, I think was Vladimir. Yeah. So already, I actually did the contrary of you. I put SOFA into a Filament executable. So it was like a proof of concept. It's working more or less, but as you could see, I think the same. Like there is no documentation for the development part of Filament in C++ at least. So I had to go through all the examples and the source code of Filament. I mean, at that time it was like 3 or 4 months ago. Maybe it changed. But so I did some work on Filament. But with Alex, maybe we could see that maybe we will go to another one. If you know the one you gave me, Alex, I don't remember his name, but maybe you should investigate another rendering engine. So for me, what I want to do in the future, I don't really know because I don't have really a lot of insights of what I'm supposed to do in the next 6 months. But as a side project or hobby, I would like to continue to work on the rendering part of SOFA. And that's it. If you have any question, you can tell me.
Yeah, question. No, maybe you just to stress what you already said, but it's that, and share that with your teammates, whether it's in Strasbourg or whatever, it's or in Leuven. It's really if you're struggling with anything, as Fred said, you can publish create issues and so on. And else, if you want to have something interactive, Twitter and so on, so that we connected and ask, just have discussions. If you don't get a reply, just get help if you need.
Just to be clear, any kind of building now some mismatch of namespace related to this particular project, right? So yes, I had some issues.
Okay. Of those plugins.
Actually, the issue is that in namespace.
All right, thanks.
I'm stopping the sharing because my connection is dying.
Okay.
So, yeah, but
we can hear the Korean ladies behind you speaking. I don't know who it is, but
I guess you can guess.
And, all right. Thanks a lot for presenting the work, and yeah, we'll together stay connected, but also with the please get back in contact with regarding Fred. And
maybe we have to talk together, but yeah.
Yeah. And
the next few days.
It's going to affect us all, I think, for the next release. We'll really be bloody in the transition because we'll have a lot of things as Fred presented. Most of the cases, you're going to have warnings, you're going to have guidance to do it. If you know, let us know that we'll do that together. Right. We'll have, so we did SOFA-NG, we'll have SOFA-Phoenix. We have like 4 others to go. I think we won't have.
It'd be nice to do one.
Yeah.
If one is shorter than the other, whether you can do it in 10 minutes sharp. Mine is shorter. Yours? Okay, let's go. Then you connect to the. Sorry, I didn't to the meeting. Sorry. Okay.
So yeah, that will be the presentation for the work on the beams, especially on the Cosserat plugin. Has already been a bit discussed by Camille and Younes before, but and while Younes is connecting, just to sum up on the two first, SOFA plus Phoenix and SOFA NG. SOFA plus Phoenix, I think it's going to be something that will continue due to the collaboration between University of Luxembourg and INRIA Strasbourg. While for SOFA Next Gen, it's actually an objective that it stops here, and the only task will be actually help on the transition. It will be, I would have said it will be a joint work between me, Fred, and Guillaume. It will be soon a single work on my end, but yeah, and Fred will remotely always be available because he's willing to. But all right, so should be ending. So only one out of the two for the moment should be continuing for the next roadmap. Go ahead, Younes.
Okay. So I will just come back on what we said last time that we do. STC.
Yeah.
From key point. According to what we are doing with Cosserat plugin. The first thing is last time we said that we developed the GitHub action for Cosserat plugin. Now we have it. It's working. But these last days we just see that we have some errors. It's related to some pull requests. Maybe after we have time to discuss with you. But this is that's happened last week, and we really understand. Can you look on it very quickly? But I think this is related to what happened so far.
Yeah, it would be the occasion to check that maybe in the coming days.
The second point is the code refactoring. We work on that also in order to match some standards of SOFA in the code we did. Like now, we are very happy to have Cosserat site on SOFA website. Yeah, it's very good for us. The third point is about working on the test-wide nonlinear strain in Cosserat plugin. What's this? First, what I will come back on what's Cosserat plugin. Like Cosserat plugin is used to simulate some kind of rules or 1D update. And to do that, we just start by dividing the code on finite number of elements, where each element is this degree of freedom. This is the dynamic location of and the goal is to use the weak form in order to approximate this behavior. When we are working on the PCS, the goal is to make the assumption that that each we divide the body in different sections, and we do the assumption on that on each section we have constant strain. Then, if this is the function of the strain, if you do this assumption, we just have this kind of behavior for the strain. As you can see, all these are errors. That's why you need to divide your plugin, your beam in very short use, very short section. Then you can have something like you can be more accurate. And the new one, the new implementation is based on nonlinear. And then to do that, we add the global approximation, and based on the backend vision function to have something more accurate. Now, then when you have large, like when you have big section, you can match more the behavior, much more the strain of the beams instead of using like linear one. Right now, I don't have some example where I can show this very different section. Where I can show this difference. right now, but I just need some implementation. In addition to show this, quickly, this is the cloud build subject to the concentric TikTok. We did the same simulation with the PCS. That show that we had quite the same result. The difference is not too much to show this is different. Like we have find a good example to show the difference. These two examples are on GitHub. And for this example, we have like analytical result, then we compare it, and it's very nice. That's what you can also look for the plastic part. Yeah, the 4 point we want to develop more unit tests for the plugin, for the PCS, for the I think the test was linear strength that we didn't implement it yet. This is also another objective for the next time. And for the I already talked about this, about the case of handling the dynamic Cosserat model. This is for the next STC. We have the linear model because in the team we have Lichao who's working on Cosserat. Right now is working on this one, which is where linear strength implemented in MATLAB, and for him it's like enough for what he's doing. And really another point, another goal is also to develop this part also inside SOPA and to see if some of like maybe for some example we don't need to go to non-linear part, we just have to stop to the linear one. That is works better. And it's more not better, but it's enough for what. And also, like already said, to have the model order for Cosserat. The goal is really to work for the contact part, because in the Cosserat project we have like one of the objects is in permanent contact with the cochlear, and for that we have computation time. We don't to compute, then we need to have like model of the part for this. That's what we do.
Yeah. On this topic, it will be of interest for various partners in South Korea that are interested by this topic, and Stéphane and Adrien are also looking at really doing this very similar stuff on they are, I think, not as advanced as you are, or not as ready to start investigating that as you are, but yeah, I'll let you know about the point.
I did that, like Christian work as we work on this, and I did also when I wrote my first project.
The 3 gray bullet points are objectives for the next, right?
The model order reduction is like it's depends on what will be the next thing. If I have the pros or if at least the guy who will come first will like
the player the terrain. Okay.
And
I can comment. So this is more related to what I've been doing. I'll be very brief because it's something very experimental still. I put it in like the unit test section because it's supposed to end in as a unit test or as tests, several tests, to do verification on the plastic behavior of the Cosserat model. So basically, the idea is that I implemented a very prototypal, I don't know how to say that, very experimental version of the plastic version model for the Cosserat beam. It works visually and mechanically in the sense that it is able to simulate permanent deformation, which is what we would expect from plastic behavior. But it uses strong assumption on the type of strain computation we have in Cosserat. And this is too strong to be used in practice. I mean, I can use it qualitatively, let's say, but not quantitatively as it is at the moment. So the idea of what I'm showing here is to do some verification on the strain computation. So I won't go into details, but I started working on that, doing some final differences computation. So it's a great point. You can see on the sections of the Cosserat beam, and the idea is to first have some use the Cosserat mapping to check the computation we make in the Cosserat space, but with quantities in the regular global frame space also. Anyway, and so the first results I hope are encouraging, and they are, let's say, giving credit to the plastic model I implemented, but there is still much to do, and I've left this pause at the moment. And if you want, you can. Yeah.
So the last point, the fact that we have a comparison from Valentina from this.
Is that a recent talk? I mean, a recent discussion that you had with her, or?
No, that's we had after the STC.
Yeah. Okay.
And the results are these results are based on the constant Cosserat. And like you can see, it's a very good result compared to Timoshenko model we already have in so far. And it's also good for us because it's the first test to show that this can be used. But here I don't have the result about the number of beams used, the number of used, but like you can see, it's a very good result compared to what already exists so far in Timoshenko. You don't have the time, the computation time also here, while the Cosserat is very faster than for this result.
And where is that? Because I see comparison with the literature data. Is that in a paper that you wrote that, or
she just used the paper to compare because
she you said Valentina? Okay.
She used paper like as ground talk, then compare what the Timoshenko in so far and the Cosserat model. Here the result and the difference is not very huge. That's why finally she said that she don't know, she will continue first on Timoshenko. But you see, for me, this is very good things. The fact that we have for many cases we have like the errors lower than the Timoshenko error, and that's very important. And in terms of computation time, we are faster, and we know that we are faster than Timoshenko.
Okay.
And this is the the constant, the PCS.
I will repeat what I said what I said to Arnaud. It's would be really good to save then when you make a bit of a really comparison with, for instance, compared to analytical solutions and stuff like that, and saving that into
for the analytical part, I didn't show you that I have a computer for that where I put all equations and everything. And this will go on GitHub. I'm just waiting.
Okay, that's really good to get such a document, and even then if it stayed like static and you don't touch anymore, but at least there is one reference document. And maybe specifying it with which version of the code you made the comparison, so that people can really get back to it and get the insurance of what you did. But yeah, and do not hesitate to ask also Valentina to do the same and maybe complete the doc and do that together.
This will be for right now. I'm pushing for that because I just had some barriers there with some project where we just lost the result. And for me, it's really nice now to have all these things somewhere, and you just put the link inside. Because you can know the Internet of Things. This is not good.
Okay, but was there anything else in the slides, or that was the end?
But I didn't put all the next goal we have, especially that it's fine.
the last one was something I added, but it's what I mentioned before. It's related to comparison between Timoshenko and Cosserat, and it's related to my work on doing navigation of coaxial instruments with Cosserat. So this would allow to do comparison between the two models, but like more advanced scenarios, let's say, because we had a lot of we have in the team scenarios where we use and even in beam adapter you find several examples of catheter navigation with beam adapter. If what I'm doing works, we'll be able to do like kind of the same things with Cosserat, and we expect it to be faster because Cosserat, the Cosserat model is reduced compared to Timoshenko's. So there is not much to say at the moment because it's too early, and I have nothing to show about that. But it's I think it can be included in the objectives for next time regarding the Cosserat thing. Okay.
I think this is kind of what we have like implementation now. For example, this test we are doing based on analytical results. And for each test, we will change. This will be like new test inside the plugin, or you can compare it. And like if you are implementing something so far, you have to match it at least. Because we know that.
Okay. Cool.
This is a link.
This kind of comparison, open comparison with first the report, what has been implemented, and the test and so on. That's very cool to achieve that.
We have adding that also the article.
Okay. Thanks a lot. We're gonna stop here to grab some lunch. Then we'll do topology, matrix, and SOP-AI. That will be on this side of the table. Christian and Aurélie will get back also for that. We'll stop here and restart. We said.